Okay, so welcome to the GSM lecture. The resources that you will have for this subject are the chapter 4 of the Schiller textbook, which goes into quite a lot of details about GSM, and also there are some supplementary notes on UTS Online, and I've also provided you on UTS Online a Wiley CD which contains a number of animated concepts of GSM, which you'll be able to have a look at. So let's get started with the lecture material. Initially, we're going to start off by looking at the GSM market and evolution. So the important things here are you need to be able to distinguish between first G, second G, 2.5G, 3G and 4G mobile technologies, and also you need to have some idea of the differences between GSM 900, GSM 1800 and GSM 1900, and what were the primary goal during the setting up of the GSM standards. So let's have a look at the market aspects. Now this slide is from January 2010, but it contains a number of important aspects of the growth of mobile subscriptions, and this particular slide is from a magazine called Informa, and the January 2010 version of it. So the first diagram, which has a map of the world, shows what is the penetration of mobile telephony in various parts of the world in 2010. Now these numbers have changed considerably since then. You can see here Europe and Australia were some of the leaders in mobile subscriptions. In Europe achieved 100% mobile subscription, which means that the number of mobile subscriptions was greater than the population, and so in 2010 they had a penetration of 120%, whereas in 2010 Australia also had a penetration of 119%. North America had not achieved 100% by then, but since then it has passed that mark. And again, on the right hand side of the slide, you will see how mobile subscriptions have grown over the past years, and you can see from 2006 to 2010 the growth in mobile subscription, and these numbers refer to millions of subscribers, has been primarily due to GSM. So as GSM networks were rolled out to many parts of mostly China, India and Africa, the growth of mobile subscribers increased. And you can also see the red portion of this graph represents wideband CDMA, and the mobile subscribers in wideband CDMA have also increased, and will eventually, as more and more wideband CDMA networks are launched in subsequent years, this red bar will increase and take over the dark blue portion. The bottom part represents the CDMA networks, that's the CDMA 2000 networks, and although there's a slight growth in them, we will find that after 2010 it actually goes down as most operators switch these CDMA 2000 networks and replace them with WCDMA networks. So we move on. Let's just look at the situation in Australia a little bit more detail. So as I told you, Australia achieved 100% penetration in early 2006, somewhere between this period here, and at this point in 2007 the number of mobile subscribers was greater than the population of Australia, which is around 20 million at that stage. And most of the subscriber market share in 2009 was between Telstra, Optus, and Vodafone, and this has continued to be very similar statistics would be observed even today. Telstra has a significant portion of the mobile subscriber market, followed by Optus and then Vodafone thereafter. Now in Australia, if we again look at the market share by technologies, over the last 10 years or so, you can see that the dominant mobile technologies were CDMA 2000, GSM, and wideband CDMA, shown by red there. And you can see that the CDMA 2000, which is represented in gray here, sort of grew a little bit from the time it was launched, but by the time we got to 2006, Telstra, which was running the CDMA 2000 network, decided to switch it off and replace it with wideband CDMA. So the number of subscribers on the CDMA 2000 decreased, and eventually the network was closed. So it was shut down in 2008. The GSM subscribers from 2002 to 2005 increased, and then as the wideband CDMA networks were launched and they became more stable and more affordable, the number of subscribers on the WCDMA network started to increase, as shown in the size of the red bar, and more and more of the GSM subscribers moved on to the WCDMA network. And so you can see that and this sort of behavior you will notice in most parts of the world. Eventually the GSM subscribers will be replaced by wideband CDMA because it offers more services than a GSM network. Okay, so we'll look at Telstra specifically because it's the biggest operator in Australia, and look at what's happening in terms of spectrum. So you can see that the most important spectrum here was the 850 megahertz spectrum, the 900 megahertz spectrum, the 1800 megahertz spectrum, and the 2100 megahertz spectrum. These were the important ones. So back in 1987, Telstra launched the first generation AMPS network, and then they gradually replaced it by a CDMA 2000 network, and then they shut down the CDMA 2000 network and they started operating the wideband CDMA network. The GSM network continued to operate on the 900 megahertz band and the 1800 megahertz band, and eventually these were replaced by LTE, and then they will be replaced by LTE Advanced in the future. And also there's an aspect of something called refarming the spectrum. So you're taking your existing GSM spectrum and you are refarming or reusing it for LTE, and also you're looking at new spectrum on which the LTE network, the 4G LTE network, can be launched. So refarming is a very important issue for operators because as I've mentioned many times, the spectrum is very expensive. So once an operator acquires spectrum, they would like to reuse it as much as possible rather than buying new spectrum every time a new technology has to be rolled out. Okay, so just a recap about mobile technologies. So we started off with first generation mobile systems, which are primarily analog based on FDMA. The one that was rolled out in Australia was the AMP system, and this was around the 80s, and eventually the first generation mobile systems were replaced by the second generation mobile system around in the 90s, and the most popular second generation mobile system was the GSM system. There were other systems in other parts of the world, CDMA based networks as well. And the problem with these early second generation mobile networks were they were based on circuit switching, and they did not have any capabilities for packet switching networks. So we had something called 2.5G, where we added packet switching technologies to existing GSM networks, so with this with GPRS, it was possible to have both service switching as well as packet switching services. And then, but the data rates were still pretty low, and around 2000, with the launch of the IMT 2000, we had the third generation mobile systems, and wideband CDMA became the most popular of the third generation mobile communication systems. And so a lot of the operators, for example, in the case of Telstra, they would have followed the paths of having AMPs in the 80s, replaced them by GSM in the 90s, and GPRS around 98, and around 2000 they started launching their wideband CDMA networks, and subsequently we had fourth generation mobile communication systems in 2010. So now that we've covered a little bit about GSM markets, let's go into GSM a little bit more in detail. So GSM was founded in 1982, and it had the initial name that was given to it was Groupe Spécial Mobile, which is a French name, and subsequently the name was changed to Global System for Mobile Communication. So prior to the development of GSM, we found that every European country had its own standard, and this was a little bit difficult, because if you travel from one country in Europe to another country in Europe, you could not use your mobile phone. So this was around the time the European Union was being formed. So they said, why don't we come up with a pan-European standard which could be used throughout Europe. And this is basically the idea behind the development of GSM. So there was an institute that was called the European Telecommunication Standards Institute, ETSI, that was formed to develop the GSM standards. And there were three phases associated with this standard, and we'll go through it. Again, one of the important things was this aspect of seamless roaming within Europe. Okay, the fact that if you are a mobile subscriber in Germany and you went across the border into France or into Holland, or you should be able to continue to use your mobile phone, and there should be some roaming agreements, and it should be possible for you to enjoy the same services that you enjoyed in your home network. So in terms of any mobile technology, what are the important aspects that a mobile technology should provide to a subscriber? Well, the most important one is the communication aspect, wireless communication, mobile. That means wherever, as you move throughout the network coverage area, you should be always connected to the network through a wireless channel, and it should be able to support voice and data services. So these are some of the basic requirements in terms of communication. Okay, and also if you move outside the coverage area of your operator, then you should be able to still have access to telecommunication services. So there should be information in the SIM card that enables you to be able to be connected. So total mobility is also an important aspect. The other aspect is that when you move from one country to another country, or even when you move outside your network coverage, you should be able to use just one number. Okay, so the GSM network should be able to handle the localization aspect, to be able to say, okay, this particular subscriber is located in this area right now, and any incoming calls should be routed to that particular area where the mobile is currently located. Okay, capacity is important. Okay, so we are always trying to achieve high capacity. Okay, we're trying to increase the number of users that are in a cell, and so we're going to achieve that by making better use of our frequencies, which is a limited resource that we have. And along with capacity, the next aspect is quality. Okay, we're trying to improve the transmission quality so users can have a better conversation over their mobile phones. Security is also an important aspect. Okay, so when we talk about security, we are talking about access control. That means being able to control the sort of services a user is subscribed for. Authentication, so we need to be able to identify a subscriber and make sure the person who's using the service is the authorized user. And then the other aspect is there's also the encryption aspect. So whatever you transmit across the interface should be encrypted so nobody else can listen to that. So GSM did have many disadvantages because it was probably one of the first digital mobile telephony systems, and the standards were drawn up before 1990, and so although it had encryption across the interface, everything that's transmitted across the interface is encrypted at the user end and decrypted at the base station and vice versa. It did not provide end-to-end encryption of user data. The other aspect was that it could not provide 64 kilobits per second to the user because of the fact that you are trying to maximize the use of the transmission bandwidth. So a number of compression algorithms are used to compress data down from 64 kilobits per second to about 9 kilobits per second. And there are other disadvantages of not GSM but all mobile telephony is that it did have an impact on driving, and there were also some aspects of health standards related to electromagnetic radiation. So these are the some of the disadvantages of GSM are listed on the slide, and you can read about these from the Sheila textbook as well. Okay, so if you look at the services that GSM provides, we see that the services that GSM provide can be mostly connection oriented. Okay, so as I said earlier, the GSM provides circuit switch services, and within the services we can classify them into bearer services. So when we talk about bearer in the context of telecommunication, we need to provide a pipe through which data can be transmitted between two access points. So bearer services are the the important service that a user provides. So in the case of GSM, the bearers we provide are circuit switch bearer. So whether we're using voice or data, the bearer is a circuit switch bearer. And the second type of service that GSM provides is referred to as telematic services, and this enables communication via mobile phones. Okay, so telephony is a type of telematic services, and there are other telematic services such as email. Again, this is all through a circuit switch bearer. And then there are supplementary services, which are services in addition to the basic services. Okay, so things like caller line identification, suppression of number forwarding, and so forth are supplementary services. Now we go on to the GSM architecture. So how does the architecture for GSM network look like? Well, GSM is a PLMN, and the acronym PLMN stands for Public Land Mobile Network. So most first G, second G, third G, fourth G networks are also referred to as PLMN. So one of the important things that they decided during the standardization process is to make the ability. Okay, prior to the 90s, you'd find that in many countries the telecommunication networks were run by governments. They wanted to move away from this concept and have the ability for many providers to set up mobile networks. And it was carefully standardized in such a way that you could also buy your equipment from many different vendors. So if you look at the GSM network, we can divide it into the mobile subscriber, then you have the radio subsystem or the RSS, then you have the network subsystem, and the OSS, which is the operation subsystem. So these are the three main subsystems of a GSM network. Now these interfaces, the UM interface, the A interface, and there are many other interfaces, ABIS interface, they were to be open interfaces. Okay, so prior to the 90s, we had the situation where every operator came up with their own standard, and every vendor had their own standards, and they were all closed standards, so you could not find the details about those standards. And it also meant that you could not buy your equipment from different vendors because of the fact that they were closed interfaces. By having open interfaces, what you're saying is everything that is transmitted on the UM interface, which is the interface between the mobile and the base station, you by making sure that they are open interfaces, every message that is sent is standardized. And so you could buy a mobile equipment from any vendor, for example from Ericsson, Sony, Nokia, and it could work with the base station that is sold by any other vendor, because of the fact that the all the messages that are sent across the interface have been standardized by the ETSI. Okay, so as I said, the three main subsystems of GSM are the radio subsystem, the network and switching subsystem, and the operational subsystems. So we're going to go into detail into each one of these subsystems in subsequent slides. So we start off with a little bit of an overview. So in the base station subsystem, the two main elements are the BTS and the BSC. So the interface between the BTS and the BSC is called the ABIS interface, and between the BSC and the transcoder TC is called the ATER interface, and the interface between the transcoder and the MSC is referred to as A interface. And within the network subsystem, we have a number of different network elements. We have the MSC, and we have the EIR, HLR, BLR. These are all different databases that you have within the system, and also the authentication center. And all of the network subsystem essentially gives you connectivity to external networks such as an ISDN network, a PSTN network, or a data network, a packet switch public data network, or a circuit switched public data network. Okay, so let's look at the radio subsystem. So in the radio subsystem, we have the BTS, or the base station, which communicates with the mobile station through the A interface, which is referred to as the UM interface. And the base station is also connected to the BSC across the ABIS interface, and the BSC is connected to the transcoder. Now the location of the transcoder is not well standardized, but most operators would put the transcoder between the BSC and the MSC, and from the MSC, the MSC is the main switch in the network, and which connects to a number of different databases through an SS7 signaling network, and the MSC provides connectivity to the external circuit switched as well as packet switched network. Okay, so another diagram which illustrates the same concept but slightly different way. The fact that you have in the radio subsystem, you have the concept of cells, and in each cell you may have one or more base stations, and these base stations communicate with users within the cell, and so the data comes into the BDS, and from the BDS it goes to the BSC, and from the BSC it goes to the MSC, and sometimes you may have a transcoder between the MSC and the BSC, and from the MSC it goes out to the external data networks. Okay, so a little bit more details about the RSS. Okay, so as we said, the radio subsystem is made up of something called the BSS, which is one BSC, and all the BTSs that connect to it are referred to as BSS. So we have one BSS over here and another BSS over here, and within this BSS we have the BTS, which is the component that's located, and you may have many BTSs in your network, and one BTS is associated with one cell, or sometimes one BTS could be covering many cells if you use sectoring. And so what does the BTS do? Well, the most important function that the BTS does is it has to communicate with the mobile station across the A interface. So it has to have a transmitter, it has to have a receiver, it has to have antennas which are located reasonably high above the ground, and so that it can provide a wide coverage. And it also performs a number of signal processing function, such as error protection, encryption, and signaling. The BSC, which is further down the network, and associated with one BSC is many BTSs. So the BSC essentially controls the BTSs that are connected to it. So the BSC, the base station controller, manages the radio channels that are available. Again, because of the limited frequency resource that we have in a mobile network. We have to manage our radio channels very well in an optimal fashion. So during handovers, when we have to allocate a new radio channel to a user, then all of those functions are performed by the BSC. Paging is another function when because we have an idea where a mobile subscriber is approximately located. So when you have an incoming call, we have to page for that subscriber and find out which is the exact cell that they're located in, and then make a connection request to that mobile station through the appropriate BTS. And then there's a transcoder function. Okay, now I mentioned earlier that we don't transmit 64 kilobits per second across the interface because it's not spectrally efficient to do that. So we compress the data. So in the mobile phone, we have PCM speech at 64 kilobits per second, which is compressed to 13 kilobits per second, and now there are even mechanisms to compress it further to 9 kilobits per second. And then this is transmitted across the interface, and once the information gets to the transcoder, it has to be decompressed back to 64 kilobits per second before it's transmitted to the MSC, because the MSC only works at 64 kilobits per second. And similarly, the data that is going on the downlink has to be compressed by the transcoder and then decompressed at the mobile end. And another function that the transcoder performs is comfort noise generation and discontinuous transmission. So basically the idea is that when you're on a mobile phone and you're chatting, when you're not speaking, there's no need for data to be transmitted across the interface. But the issue is the person who's listening might hear blank noises when data is not transmitted. So what we do is we artificially generate noise, and this is referred to as comfort noise generation. Okay, so this table here tells you important tasks that are performed by the BTS and the BSC in a mobile network. So the BSC is responsible for the management of radio channels, as we mentioned during handover. We need to be able to allocate new radio channels to a mobile subscriber, and that function is performed by BSC. And then we also have functions such as frequency hopping. So frequency hopping is a function that is performed in a number of mobile networks, and the idea is that the frequency that you're using for communication keeps changing. So you keep hopping from one frequency to another frequency, and the basic idea is that by hopping you are sort of trying to minimize the effects of fading that can occur in a mobile network. So these are some of the important functions that are performed in the BSS. So some functions are performed by the BTS and some are performed by the BSC. Next we move on to the network and switching subsystem. So the main component of the GSM PLMN is the network and switching subsystem, because this is the one that enables a mobile subscriber to be connected to a service that they want. Okay, so for example, all a mobile subscriber wants to know is, okay, can I make a telephone call to a PSTN, for example? Can I connect my mobile phone to a data network? Could be a packet switch data network or a circuit switch data network. So in terms of providing that connectivity to these external networks, all of the services have to be handled by the NSS. So switching is the important function that's performed along with mobility management, interconnection to other networks, and charging. Obviously, we have to charge subscribers, otherwise, that's how the operator will be able to recoup the costs that they have invested in the equipment. So, in terms of the components of the NSS, the main component of the MSS is the MSC, Mobile Services Switching Center, and this is usually a very expensive piece of equipment, and you will see that the same MSC will continue to be used in a 2.5G as well as a 3G network. And so everything is switched at the MSC. Okay, so even if two subscribers are talking to each other in the same cell, the data has to go all the way to the MSC where it's switched and sent back to the same cell. So MSC is considered an important function, and sometimes you may have a limited number of MSCs in a network. And you have a series of databases in the network. HLR is the main database, which contains information about all the subscribers. So it's a central master database containing user data, and information in the HLR is downloaded to a VLR. So associated with each MSC is a local database, and this local database contains information about subscribers that are being served by a particular MSC. And so it downloads from the main database information that is relevant to providing services to a subscriber. And then you also have the EIR and Authentication Center, and these are now considered part of the OSS. So let's look at the OSS next. So OSS is the operational subsystem. So this is where we provide a number of network management functions, and also a centralized operation of the GSM network. So you see the operator interacts with the mobile network through the OSS system. Okay, so the important components are the authentication center, which is associated with some of the security functions of GSM. So it generates the parameters that are needed to authenticate a subscriber. So usually the authentication center will get a request from a VLR, and it'll send it specific security parameters which can then be used for authenticating a user. And it also includes this security information includes information needed for authentication as well as encryption. You also have something called the EIR, which is part of the OSS, and this is associated more with the handset. So the difference between the authentication center and the EIR is the authentication is more to do with the SIM card, whereas the EIR is more to do with the handset. Okay, so sometimes you may want to ban certain handsets from being used on the network. For example, if it's stolen or if it's malfunctioning, sometimes handsets can malfunction and which can cause interference in a system, and an operator might decide to shut down a particular handset from being used. So associated with each handset is a unique identity, and which can be used by an operator to turn it off from being used on a network. And then the third and most important part for an operator is the operation and maintenance center, through which an operator can control a number of parameters in the BTS, in the BSC, and any network element in a mobile network. Okay, so the question now, when they were designing the HLR and the VLR, do we want to have a distributed VLR? We've already said that the HLR is a centralized network element, and you may have a limited number of HLRs in a mobile network. But we want to have, do we have a centralized VLR, or do we have a VLR associated with the MSC, a distributed model? So most operators use a distributed VLR model, primarily because we are trying to, an MSC has to interact with the VLR quite a bit, and if you had a centralized VLR as shown in the diagram on the left hand side, you see that there is going to be a lot of signaling traffic between the MSC and the VLR, and this signaling traffic can result in significant delays in provision of services. So the model that is more suited is to have a distributed VLR where an MSC is co-located with the VLR, and so data exchange between the MSC and the VLR can be very quick. And the last subsystem that forms a GSM is the mobile station, and a mobile station can be consist of the mobile terminal, okay, and the mobile terminal is the hardware that allows communication with the base station, okay, and again this information about mobile terminus is held in the EIR. And then there is the SIM module, okay, and the SIM within the mobile terminal contains information about the subscriber and the services that they are subscribed to, and there is a close association between the SIM and data in the authentication center. And it's possible to take the SIM and put it on, it should be possible to take any SIM and put it on any mobile terminal and still be able to use the services of the network. That's the mobility aspect. And sometimes you may have a terminal adapter. For example, you may have a computer which is a terminal equipment which you want to connect through your mobile terminal to be able to connect to data services. So you may have to have a terminal adapter modem that provides adaptation of your data from the terminal equipment to the mobile terminal, so that the data can be transmitted across the interface. Okay, so this is a slide from Nokia training course, which shows how the different pieces of equipment will look like. So many different types of base stations. You can have very simple base stations that could be mounted on a wall, or you could have an entire rack as a base station. Similarly, if you go into an exchange, you see a base station control. It looks like a cupboard, but if you open the cupboard, you'll find racks of equipment in it. Okay, let's stop here for the time being.